Hi, my name is Jesse Garcia. I'm the current president of the Husky Game Dev Club, and I just wanted to welcome all of you to our first event of the winter quarter. Um, with me today is Jesse Garcia, myself.
I'm Hal. I'm the technical director, and I like making games.
I'm Kyle Huynh. I'm the vice president. I like to do art.
I'm Vincent Allen, one of the advisors and the previous president.
And now I would like to pass it over to Kyle.
Yeah, so something to note, this upcoming the February 18th is when we'll be hosting our winter quarter game jam. So be on the lookout for more announcements on that. Next slide. Okay, so here's our general timeline for our upcoming events we have planned for the quarter. Today is our first general meeting, and exactly 2 weeks from now, on February 3rd, we'll be having our second general meeting. We'll be following up this workshop with a player movement and camera script workshop. On February 17th, we'll be having a more casual general meeting since it is a day before our game jam. And on the 18th is when it officially begins. And on the 20th, when it finishes, we'll be following it up with our showcase. Next slide. So what is the intro to game dev workshop series? So we'll be holding multiple workshops throughout this quarter aimed towards beginners and people who are interested in coming into game development. We hope the series will help give you some foundational knowledge and tools for you to explore and potentially apply to your participation in the Winter Game Jam as well. Next slide. Yeah, so for the agenda, here are the key topics that we'll be covering. We'll be going over the roles in game development, some helpful software to help you create your games, parts of a game, and a simple beginner Unity demo. Next slide. So to understand game development, you'll first have to know the roles that make up the team. Next. So the first role to talk about is the artist. Obviously, an artist can fit many different roles, but here are the most common that appear in game development. First, we have a concept artist, which helps create a visual representation of an idea for use in your game. They are really helpful. They really help give a first hand in helping visualize how your game might look. There's the 3D modeler and 3D animator. These are pretty self-explanatory, obviously necessary for any games you might be doing in 3D. There's the character animator that design and create characters and bring them to life through movement and animation. There's an environment artist, which helps create backgrounds and sceneries for video games. Then there's the special effects artist. They basically make anything that moves that isn't a character, anything from sparkles to explosions. And lastly, there's the technical artists who kind of act like a bridge between artists and programmers. Next. The second role is the programmer. There are many disciplines within the programming role, as you can see here. Their role is to write the code that brings the video game to life and is usually working closely with the game designer and artist to translate the project's vision into a fully functioning, playable game. Next slide. Vincent.
Awesome. So there are many types of designers, but we're going to focus on three. There's the level designer, the systems designer, and then the story designer. Level designers typically focus on like the environment, usually with some kind of like specific goal in mind, like if you're doing a competitive game, where are the choke points? Where is like safe spots on the map, right? Or for like platforming, where the platforms are placed, or where objects are placed, right, etc. Systems designers are more along the lines of like the rules of the game. So think like the rules of a board game, how like if you're doing like a card game, what a certain card does, how does a certain mechanic work? Do I need to like reload my gun, or does it have like infinite ammo, etc. Story designers are more on the narrative side of design. So think like games like Mass Effect or Dead Space, etc., that have like the story behind them. A story designer would design essentially the story behind those games. Yeah. Next slide. Awesome. So there are many types of leaders too. Some of the ones we'll go over today is the producer, the technical director, creative director, and sound director. Oftentimes directors are only required for like the larger teams, typically like the tens to hundreds of developers. Like a creative director, if you have like teams of artists, right? A creative director is the person who manages those teams. A technical director is kind of on the same vein, where you have like teams of programmers. The technical director manages all of those teams. Same thing with sound. And essentially, if any of those teams or any individuals on those teams have any issues or roadblocks, they're the ones who are kind of in charge of finding solutions to those roadblocks. The producer is the same. You'll find them on larger teams and smaller teams. Usually, like for instance, on smaller teams, think like under 10 or a little bit over, right? The producer does essentially the same, where if anyone has any roadblocks, they help with solving those roadblocks. They also help with task delegation. So like in Scrum, Kanban, etc., they operate those project management methodologies with their team. Yep. Next slide.
Yeah, so that covers the game development roles. We'll be passing it off to our technical director, Hao, who will be covering the software portion of this workshop. Next slide.
Thank you, Kyle. So yeah, in the next few slides, I'm going to talk about some software and game engine that will really help you on your game dev journey. Next slide. So the first game engine that I'm going to talk about is Unity. So most of you may have already heard of Unity. Unity is an extremely powerful and very flexible game engine that favor heavily toward scripting. It is fairly easy to use if you already have experience in game development. It's a good way to learn C#. Something to keep in mind that if you are someone who wants to avoid scripting, you can use the visual scripting tool on the asset store, which is called Bolt, for node-based programming. I remember that you need to buy Bolt, but I think recently it got acquired by Unity, and you can get it for free in the asset store. So good on Unity for that part. Since Unity is such a popular game engine, there are a very large amount of tutorial and resources for beginner and experienced game developer alike. And if you're a student, you have free access to the professional version of Unity that gives you exclusive discount on the asset store and many more exclusive feature. And since Unity is one of the most popular game engines right now, I think 45% of game development is done in Unity, and which is basically half of the market. And the reason why it's so popular because it provides developers tons and tons of features to make 2D and 3D games, and it's free for personal use. And I know that Unity support up to 25 plus platform, so it have great portability. And yeah, next slide. So here are some game that was made from Unity. So Hollow Knight, Super Hot, and Among Us. So next slide. So I'm going to pass it on to Vincent to talk about Godot.
Awesome. So Godot is a free and open source game engine. It supports multiple languages, and it even has its own language. Some of the languages that it supports is C#. It has full C# support. C++, GD script is its is its custom language. And it also has a visual scripting language. If you're familiar with Python, then you should be able to pick up GDScript fairly easily, as it's a Python-like language. And then there is also some community-supported languages such as Rust, Nim, D, and some other languages. Godot excels most as a 2D game engine. However, it has a fairly good 3D support too. If you're new to game development and you haven't developed on an engine before, it should be easy to, or it should be easier to pick up on Godot's interface. However, if you already have some experience, Godot definitely has a different workspace and development flow than other languages. So it is a bit more difficult to pick up if you're already familiar with other game engines. Next slide. So we're not going to go over the video right now. However, there are plenty, I do want to mention there are plenty of beginner tutorials. There's a pretty active Reddit. Even though it's considered one of the less used engines, it is a very fast growing community. So you should be able to find lots of help online and lots of documentation. Next slide.
Okay, awesome. So here's another popular game engine that everyone might already know. It's called Unreal Engine. Unreal Engine is owned by Epic Games, and the first of its generation was released over 20 years ago. So it's a very old engine, and Unreal Engine is extremely complex tool for creating complex game. So if you have little to no experience in programming, be prepared for a pretty steep learning curve with C++, that is scripting language. Also, I think C++ is a little different from standard C++ because Unreal have their own garbage collector and other feature. And overall, I think Unreal Engine is a very powerful game engine to create a really good looking game. And as you can see, a lot of big company use it to create a AAA game. And next slide. So here are some games that was made by, in Unreal Engine: Mass Effect 3, Fortnite, and XCOM 2. Next slide. So the next quote unquote game engine, this one is Pico 8. The Pico 8 is basically really different from the previous game engine that I talked about because it's more of a game than an actual game development platform. Doesn't mean that you cannot make game from it. Pico 8 is simply a virtual machine designed to mimic a fantasy video game console. Coding is done in Lua-based environment where people can create game, maps, sprite, and sound from it. And the platform is very community driven and it's very good for prototyping quick concept. And if you want to get started in your game dev journey, I think Pico 8 is a good alternative to the previous game engine that I talked about. Next slide. And so as you can see on the screen, Super Hot was actually remade on Pico 8 fantasy console, which actually made by the Super Hot team. So pretty cool. So you can actually make a lot of cool stuff on Pico 8. And yeah, next slide.
Yeah, so we'll be talking about some other programs that are not required, but definitely helpful for your journey in game development. Next. So Sprite is a good program if you're looking for that pixel art aesthetics for your video game. It's very simple and straightforward and does animation and sprite sheets, as well as the palette tools give you lots of control over the colors in your artwork. It costs about $15. I wouldn't say it's required for someone who wants to get into pixel art, but it definitely has definitely makes your life a lot easier when you're creating your pixel art. Next. So if you're looking to make a 3D game, you have to get looking into Oh, you have to look into getting a 3D modeling software, and one of the best softwares to choose in that department would be Blender. Blender is completely free, and it's really powerful and can cover things like modeling and texturing to rigging and animation in 3D. We've linked a few guides on the fundamentals and getting started with Blender. And yeah, next slide. Be passing it off to Vincent.
Awesome. So the next software that we recommend is Trello. This is a really easy and free way of managing your projects, whether you're on your own or with a team. You could use them or use Trello for something as simple as kind of a like reminders or a to-do list, to something as complex as like a Scrum or Kanban board for like a whole team. It's really easy and very intuitive interface, and you can have unlimited users for free. They have paid features on there, but none of those paid features are required to use Trello in a pretty much vast amount of ways. Yeah. Next slide. Awesome. So Git is is another software we highly recommend when developing games. It makes backing up your game really easy, and then it also makes collaboration very easy, or a lot easier than not having Git. It's free and open source, and essentially what Git does is it allows you to upload a project or the files related to a project into a repository. And then if you have like a collaborator or someone who's working with you, they can clone that repository, work on the same exact files that you were working on before, or they get a copy or a clone of the project that you had been working on before, and they can make edits and push those to GitHub, or push those to the repository, and then you can do the exact same. So it's essentially a way to work on the same project, but over multiple computers. And like I mentioned earlier, even if you're not in a team, it's important to back up your projects, and GitHub is a really good way to do that. You can even revert some, or like if you make like a bad push to your repository, you can even revert some of those changes, which is really important. The one thing I will mention is for Unity. Unity doesn't have very good Git support. Oftentimes, if you try to use Git with Unity, you'll find that you have merge conflicts, which means that there's conflicting files on the repository compared to your copy of the project. This is just because of how Unity is designed. There are ways to get around it, but it does take a little bit of research and practice, and we will probably go over it in like a future, or go over it a little bit in like a future workshop or event. Next.
All right, thank you, Vincent. Yeah, I definitely highly recommend you use Git for all of your programming project if you can, even if it's a solo project or in a team. Yeah, so highly recommend Git if you're gonna use for your project. So and yeah, so in the next few slides, I'm going to talk about some mechanic that you'll be most likely going to implement as a game dev. And after that, if you want to stick around, I'll be doing a brief demo about Unity and talk a little bit about the fundamentals. So yeah, stick around if you guys are interested. And I want the demo to be aimed for people who are new to game dev and want to learn more about game engine, like how Unity work. Okay, next slide. So here are some mechanics that you might have already seen when playing game, and some mechanic that you're going to implement as a game dev. So player movement, AI behavior, combat, utility power, and so much more. I'll be going over the first two, which is player movement and AI behavior. Next slide. So for player movement, if you're a gameplay programmer, these mechanics would be the most likely thing you'll be implemented. Almost all games have player movement, but almost all of them is implemented differently, such as an RTS game, you move your mouse, so you have like your unit and then move them some way. And other well-known example is Super Mario, where you can jump from platform to platform. Is a side-scrolling game. And for first and third person game, you'll be moving your character from a 3D space, and the camera will be attached close to your player. And yeah, that's basically just a play movement. Next slide. Another important mechanic is enemy AI. This implementation is depend on your game design, but it can get complex pretty fast if your game is complex enough. Most well-known one is enemy movement or AI chasing the behavior. This can be implemented in many ways, such as so some possible algorithm is ASO algorithm, ray tracing, and finding a player position in your game or space, and handled by your game engine and move the AI object toward your player. And these implementations can be very complex or very simple, depending on the game that you are making. Yeah. And yeah, that's the basic gist for enemy movement. Next slide. So I think that's it for introduction to game dev. Do you guys have any questions? So if none, then I'll be moving on to the demo now. Okay, can you guys see my Unity hub?
I see Unity Hub, but is there a window that popped up when you hit new?
Okay. All right, so once you have your Unity open up, before that, I'm going to talk a little bit about Unity. So the cool thing is that Unity have a lot of APIs that you can use to interact with it. So once your Unity is done loading and created, you guys will see this window. What I want you to do is I want you guys to focus on four main panel. So the hierarchy window, this window right here. This hierarchy window is going to contain a list of every game object in the current scene. And then the next scene is the scene view. This scene view is where you're going to be creating your game world, be it scenery, background, character, and camera, and all kind of game object. Game object is a fundamental concept in Unity that represent everything in the scene. So that means that like your character, props, and many more. A game object is functionality is defined by the component attached to it. So you can see your game object in the, so if you click on the game object like this main camera, and inspector window should pop up on the right side. And each one of these transform camera is a component. And every game object in Unity always has a component, a transform component. It is impossible to create a game object without a transform component in Unity. This component is really important because it's defining the game object position, rotation, and scale in the Unity scene itself. So this component right here. And the transform component also enables something called parenting, which is one of the most important thing while working on with game object. So, and then the next window is the project window panel down here, which will display all the files pertaining to your project, such as script, audio file, and sprite. So everything here will be in your project file that you can click on project. So I'm actually gonna clear on my annotation. So let me try to create a really simple game object. So Unity actually already provided a prefab to create some simple 3D objects such as a cube, sphere, and capsule. So I'm going to create a cube. So when I click cube, a simple 3D cube should be put into my scene. And as you can see on the right, that's actually my game view. So this game view is basically what the players see. And in the scene itself actually have a different camera, which is called the scene camera, where you can move the camera around using your mouse to basically move the scene camera around to edit your game object. And then, as you can see, the main camera is where what the player is seeing. And let me click on the cube. So this cube have 4 components to it, and actually 5 components, which is including the material. So this cube have a transform component to talk about. So, and then whatever I do in this, change the component around, I change the game object functionality. So I can also attach the script to this game object to define some functionality by myself. So let me create a new script. So to create a new script, you just go down to your project window, or if you click on cube itself and add component, you can name your script. So call this simple script. And then there should be an option to create a new script. Create new script, then name it simple script or whatever you like. And then if I open up the script, the default IDE that Unity is going to use is Visual Studio. And wait for it to load. So once you open up that, you should see something like this. So every script that you create in Unity always inherit from model behavior. So model behavior is a really important concept. So every script that in Unity inherit from model behavior, that means that is telling Unity that you want this script to work with Unity. So if your script doesn't inherit from model behavior, that means that Unity won't know how to deal with that script. And if your script also doesn't have model behavior, you won't be able to attach the script to a game object as a component. So once I have the script open, I can do print out stuff. I can print out the name of my game object. So in debug. And then I forgot to talk about the store and update function. So the store function is what happened. So once you attach this script to a game object, the store function will be called at the first frame once the game get played, and after that, the update function will be called once per frame, basically. So if I go back to my Unity, and I can attach this script to Unity, since I actually add component, you add component to and create a new script to it. It's already attached to my cube. But if it wasn't attached, so maybe remove the script. So to attach to a game object, all you have to do is you drag the script, then drag it to the game object you want to attach the script to. So now if I click play, so now every frame is gonna go to the update function, and it's gonna start printing out the name of the game object, of this game object that this script is attached to, which is the cube. So as you can see in the console, is printing out every single frame. My game object name is the cube. Okay. So yeah. So yeah. So really important stuff. All thing you have to care about is the hierarchy window, the scene panel, then the inspector panel, then lastly the project panel. And all of this is where you're going to basically edit and create your game in the Unity game engine. So these are the fundamentals that I want to talk about today. So for the next workshop, we're gonna create a simple 2D game. So if you're interested, the next workshop that we're gonna host is we're going to create simple 2D games where we're gonna touch upon player movement, scripting camera, and doing some simple physics that Unity already taken care for us. So now I'm gonna pause the recording here.
The movement and camera scripts. Well, hello to you too. So, as I was saying, I hope that we're able to do this again in 2 weeks for our general meeting. That one is going to be about player movement and camera scripts in Unity, and that will be taking place on February 3rd. It's going to be a Thursday, and it's going to be from 6 to 7 p.m. Vincent?
Awesome. So I just want to give a huge thank you to all of the people that we've listed here for the credits. We've actually done this presentation before, this intro to game dev presentation. We updated it a little bit to be a little bit more relevant. But we made this presentation in collaboration with the ACM. I've listed the ACM officers here too. So huge thank you to everyone on this list for helping contribute to these slides, and thank you to everyone here right now too. One other thing before we end off, see if I can get this posted. We are looking for officers. For the chat, I'm going to post the link to the officer form. If you're at all interested in being an officer, we could always use the help. The more officers that we have, the more general meetings we can host, the higher quality game jams, and just more stuff in general. We have all kinds of ideas on stuff we want to do, and just all we need is just more people to help out with executing those. So if you're at all interested, that form is there, but no worries if not. I'll of course be announcing the link on the Discord too at a later time. But yeah, that's it for me.